Physics, Chapter 17, Circular Motion, Video 1. First of all, we need to identify what circular motion is. Obviously, there is a central point. Around this central point, at a fixed length, which is obviously radius, at a fixed length, something is moving. So it doesn't really have to move a complete circle, because we might not get that kind of situations. For example, when a car takes a turn, or when it goes through a bend, there is circular motion involved, but it doesn't really go the entire circle. But if you take a wheel of a car or a bicycle, then any different point other than the center will be moving in a circle around that central point. So the examples here they have given, the wheels of a car or a bicycle, you understand what circular motion is, the hands of a clock, etc. Then we have to look at different aspects of circular motion. So now different from direct, that is straight line motion. Now in straight line motion, we know that we have two quantities that we can talk about, velocity and speed. So velocity is a vector quantity because it has a direction. In straight line motion, we can talk about the direction, but then in circular motion, the direction changes all the time. So if the direction changes, if one of the two factors, that is the quantity or the direction, changes in speed or velocity, in speed, the velocity is changing. So that if the velocity is changing, you need to understand that there should be acceleration. For velocity to change, there should be acceleration. So if the direction is to change, there has to be some sort of a force acting on it. That is for according to F equals ma, Newtonian law. Unless there is a force acting on it, what is the rule? What does the law say? Unless there is an external force acting on it, rule number 1, Newtonian rule number 1, unless there is a force acting on it, any object would continue to move in a straight line. But if it is not moving in a straight line, because in the point here is, the point that we need to make is that in circular motion, we are looking at in straight line motion, things would be moving in a particular direction. So there is no change in direction. But if you take circular motion, it is moving like this. So the direction is changing. So if the direction is to change, there has to be a force acting on it. So if there is a force, you need to understand that if there is a force, there has to be an acceleration, because F is equal to ma according to Newton's law. If there is a force, there has to be an acceleration. Right? So basically, this connection you need to remember. So this is the reason why circular motion has movement. Circular motion has change in direction. Circular motion has acceleration. So coming back to our point, our discussion. Now in a circle, if you take a circle, any circle, there is a central point, the center, and this length is the radius, and this length is 2 pi r, which is the circumference. So those details you must understand. You must know 2 pi r. Right? When you do calculations for pi value, you have to input the pi value on the calculator. So with those basic details, let's move on to uh, the other details that we need to learn. Now, when talking about circular motion, we have to talk about displacement. That is, how far does it move? But here we can't talk about in length. Now, for example, if the movement starts at this point O, if it starts and if it moves up to this point A, this is the displacement. But because we cannot actually we can talk about a length from here to here, but that doesn't really give us an idea, because we don't know how far apart from how far from the center, etc. We can't know. Then we talk about angular displacement theta. So we talk about this angle through which something moves. So this angle through which, the angle or the arc through which object moves has moved from its starting position. So this is the starting position. So from the starting position up to the end, how far has it moved is what we refer to as angular displacement. So that is the definition. The angle theta through which, if you want to write down a note, the angle theta through which the object has moved from its starting position is known as angular displacement. The angle theta through which an object has moved is known as its angular displacement. So you would be able to answer question number 1 now.